Every single thing you eat, every breath you take, every time you fall asleep, it's running on code that's 4 billion years old. And somewhere in that code, right at the very beginning, there's a gap nobody has ever fully explained. Scientists call it abiogenesis, the moment non-living chemistry became living biology. And here's the uncomfortable part. We don't actually know how it happened. Not we have a rough idea. Not we're close. We genuinely do not know how a planet full of rocks, water, and gas turned into something that could think, feel, and ask where it came from. And the closer you look, the stranger the whole story gets. Let's start with the timeline, because the timeline alone should bother you. Earth formed about 4.5 billion years ago. For the first several hundred million years, it was basically hell. Molten rock, constant asteroid bombardment, an atmosphere that would kill you in seconds. Then, somewhere around 3.8 billion years ago, life shows up. Not simple pre-life chemistry, actual self-replicating, metabolizing life. That means life appeared within about 700 million years of the planet becoming survivable at all. In geological terms, that's not slow. That's almost immediate. Imagine a house fire finally getting put out, and by the time the smoke clears, there's already a fully furnished apartment inside. That's roughly the speed we're talking about. Biologists have never fully explained why it happened that fast. The standard model, primordial soup chemistry slowly assembling amino acids into proteins, into self-replicating molecules, requires enormous amounts of trial and error. Billions of years of trial and error, according to most lab simulations. But Earth didn't have billions of years to spare. It had a few 100 million, and somehow that was enough. So where did the raw material even come from? This is where things get even weirder. In 1969, a meteorite fell over Murchison, Australia. When scientists cracked it open, they didn't just find rock. They found over 90 different amino acids, the exact building blocks used by every living cell on Earth. Which means the raw ingredients for life aren't unique to this planet. They're floating around in space, hitching rides on rocks, just waiting for somewhere to land. And we know life itself can survive that kind of trip. Tardigrades, these microscopic creatures barely visible to the human eye, have been frozen near absolute zero and exposed to the total vacuum of space. They survived all of it. In 2019, a spacecraft carrying tardigrades crashed on the moon, and there's a real possibility some of them are still alive up there right now, sitting in the dust, waiting. So we have the ingredients arriving from space. We have proof that biological material can survive interplanetary travel. And we have life appearing on Earth far faster than known chemistry should allow. None of that proves anything supernatural. But it does mean the simplest explanation, life just randomly assembled itself here from scratch in record time, isn't as airtight as most people assume. In 1973, Francis Crick, the man who co-discovered the structure of DNA and won a Nobel Prize for it, published a paper proposing something called directed panspermia. His theory was that life on Earth might have been deliberately seeded by an intelligent civilization elsewhere in the galaxy. This wasn't a random YouTube theory. This was one of the most respected biologists in history, looking at the data and saying, the pieces don't fit together as neatly as textbooks pretend.
Now here's where it gets even stranger, because it's not just our origin story that doesn't add up. It's our bodies.
Every other species on this planet is built for the environment it lives in. Fish have gills, birds have hollow bones for flight.
Polar bears have fur dense enough to survive Arctic winters. Evolution tends to fit an organism to its surroundings with brutal efficiency. And then there's us. We burn under our own sun. Not get uncomfortable, burn. We had to invent a chemical paste, sunscreen, just to walk outside without damaging our own skin. No other mammal needs to do that. Dogs, cats, elephants, horses, none of them require a protective layer of synthetic goo just to exist under the same star we evolved beneath. Then there's your back. Roughly 80% of humans will experience chronic back pain at some point in their life. When 4 out of 5 members of an entire species share the same structural flaw, that's not bad luck. That's a design problem. Our spine is essentially a horizontal structure evolution tried to force into a vertical position. Kangaroos and ostriches, other animals that stand upright, don't have this issue because their skeletons were built from the ground up for that posture.
Ours was retrofitted, badly, from a 4-legged blueprint.
Then there's childbirth, which is somehow worse. Human childbirth is the most dangerous birthing process of any mammal on Earth. Our babies' heads are so large relative to the birth canal that before modern medicine, childbirth was one of the leading causes of death for women throughout almost all of human history.
A horse gives birth in under an hour, and the foal is standing and walking within minutes.
A human baby can't even support its own head for months. We are born more helpless than almost any other creature that has ever existed.
And then there's the strangest one, the one that has nothing to do with your body at all. It's what's happening inside your head. No other species on this planet knows it's going to die. Dogs don't lie awake at night contemplating mortality. Dolphins, despite their intelligence, show no evidence of existential dread. Elephants mourn their dead, but they don't build entire civilizations around trying to answer what happens afterward.
We do. Every human culture in recorded history has built temples, religions, and philosophies specifically to cope with the fact that we know with total certainty that we are going to stop existing.
What survival advantage does that provide? Evolution rewards traits that help an organism survive and reproduce. Constant, unshakable awareness of your own death doesn't obviously help with either. If anything, historically, it's driven people to despair, war, and irrational decision-making.
It's the kind of trait you'd expect to find in something that's slightly out of place, conscious enough to sense something is wrong, but never quite able to name what it is.
Now, to be fair, mainstream biology does have answers for most of this. It's called evolutionary mismatch, and it's honestly one of the more compelling explanations in modern science.
We only started walking upright around 6 million years ago, which sounds like a long time, but evolution moves on a much slower clock than that. 6 million years isn't nearly enough time to fully redesign a skeleton that spent hundreds of millions of years optimized for 4-legged movement. The sunburn issue traces back to losing our body hair, likely to cool down more efficiently while running long distances across open savanna.
Trading fur for sweat glands so we could hunt in the heat, childbirth danger comes from something researchers call the obstetric dilemma. Our brains getting bigger faster than our pelvises could widen to accommodate them. Evolution was optimizing for intelligence and upright posture at the same time, and something had to give.
It gave at the birth canal, so the science does explain most of the specific complaints.
But here's the thing it still can't fully explain: the speed of everything else we did afterward.
Dolphins have existed for around 50 million years and have never built a single tool.
Chimpanzees figured out sharpened sticks roughly 4 million years ago and haven't meaningfully upgraded since. Humans went from sharpened rocks to nuclear weapons in about 2 million years, from fire to space stations, from cave paintings to artificial intelligence. 200 years ago, we had no railroads. 125 years ago, no airplanes. 75 years ago, no presence in space at all. Nothing in the 4 billion year history of life on this planet has ever accelerated the way human technology and intelligence has, and scientists still don't fully agree on why. Some researchers point to language, others to cooking, which unlocked more calories and allowed our brains to grow larger. Some point to a specific gene, FOXP2, tied to complex speech. Others credit our unique ability to teach, to pass accumulated knowledge across generations instead of starting from zero each time. All of these probably played some role.
None of them, individually or combined, fully explain why our specific species jumped so far ahead so fast, while every other intelligent species on Earth crept forward at a crawl.
So, where does that leave us? Probably, almost certainly, we are a product of this planet.
The evolutionary evidence for mismatch theory is strong, and it accounts for the vast majority of our physical oddities. But almost certainly isn't the same as definitely. And when one of the most respected scientists in modern history looks directly at the data and says something doesn't quite add up, that's not fringe thinking. That's science doing exactly what it's supposed to do, asking uncomfortable questions and refusing to pretend the answers are cleaner than they actually are. Maybe that discomfort is the point. Maybe the same restlessness that makes us build telescopes and send robots to Mars just to see what's out there.
It's the same restlessness that makes us ask where we came from in the first place?
If we are entirely from here, then we are the strangest thing this planet has ever produced. A species that burns under its own star, breaks under its own gravity, and still can't stop looking up. And if we're not entirely from here, then in some sense, we've been trying to find our way home for 300,000 years, and most of us never even realized we were lost.